All right, everybody. Hello, welcome back to another video. And in this video, we're going to be taking a look at a question from a paper one, from an HL paper, and it's from the November 2019 batch. So this question requires us to calculate the enthalpy of combustion of ethanol in kilojoules per mole. And we are told to do this using the Q is equal to MC delta T equation. And they've not told us to give the final answer or what the one number answer will be, because of course it's a paper one and you don't have a calculator, so it will be a bit unreasonable to expect you to do such calculations mentally. Therefore, they have just asked us to give our final answer in the steps that we take to get to, or the steps that we would take to get to the final answer if we had a calculator. Now, these type of questions, I have seen them come across in or come up in many papers, in both paper one and two. And for a long time, even I didn't know how to solve them. However, in the past month or two, I've realized it is actually much simpler than what it appears to be. And hopefully, I can help you learn this concept and you'll be able to ace any question or any such question that comes up in future exams. So, what is the enthalpy of combustion of ethanol in kilojoules per mole? Now let's look at the first part. In order to, the first thing we should do is we have to use this equation. Let's calculate Q. So Q is equal to M times C times delta T. Now what the hell is Q? You must be wondering. Q is basically the symbol for the heat energy given out in joules. And in order to calculate how much of heat energy is given out in joules, this is the equation. And how would we do this? What is this thing? So M is mass. So M is mass in grams. C is the specific heat capacity of water. And we just assume this to be true, or we assume C to be 4.18, which is the specific heat capacity of water for all solutions. That's what we just assume it to be. So it'll be 4.18. And now remember, this is only applicable in the IB. I am sure that in higher level chemistry, or I mean not higher level, I mean in university level chemistry, you would definitely have something different. But I'm not aware of that because my knowledge is limited to the IB diploma program. And in the IBDP, you always assume that the specific heat capacity, or C, is 4.18. And delta T is simply the change in temperature. Now the change in temperature, remember, it's the change in temperature, not what the final temperature is, not what the initial temperature is, it is the change in temperature. And this change doesn't have to be in Kelvin, it can be in anything, any units, as long as the units that you are finding the temperature change in is the same as the units the temperature was measured in initially. So supposing we can see over here that the maximum temperature was 30 degrees and the initial temperature was 20 degrees. So that means that the temperature change was an overall of 10 degrees Celsius. Now, if I convert this to Kelvin, that would be completely wrong because the units of the temperature measured is in degrees Celsius. So I have to also keep this in degrees Celsius. So it really doesn't matter what the units of temperature change is, as long as it's same to the units that the temperature was measured in the question itself. So if supposing this was not degrees Celsius, and if supposing they had given they had measured the temperature in Kelvin, then I would have to convert this to Kelvin, but they have not done that. They've left it in degrees. So we are also going to leave it in degrees. And for the mass in grams, they've already told us the mass in grams of water. They've told us that it is 100 grams. So we are going to write this as 100. And in this experiment, essentially what is happening is that ethanol is being burned. So it looks something like this. So you have ethanol in here. This is a little flame that comes out when you burn it. I know it looks a bit funky, but it's a flame. And you have a beaker of water which is just randomly floating on top here, and you have water inside here. So inside here is water, and inside here is ethanol. And you know that ethanol is very combustible. It easily burns to make a fire. This is a thermometer. I'm sorry for that very weird looking thermometer. So this is a thermometer. And this is basically the setup. So they're asking us to calculate the enthalpy of combustion of ethanol using the data gathered from this water over here, because we can't directly calculate what the combustion of ethanol is. There's no a tool to do that. So we use these steps to get to the final the combustion or the enthalpy of combustion of ethanol. And we do that using this equation over here, and a few other steps which I will get to now. Anyways, sorry. So we know that the mass of the water in the beaker is 100 grams. We know that the specific heat capacity of the water in the beaker is 4.18. And we know that the temperature change of the water in the beaker, which we measured using that thermometer, that weird looking thermometer that we had placed in the beaker, we know from that the temperature change is 10 degrees Celsius. So it would be 100. So Q would equal to 100 times 4.18 times 10 degrees Celsius. So this is essentially the heat energy, or the amount of heat given out in joules. So this is the amount of heat in joules that was given out by the burning of this much mass of ethanol. Now, in order to find out the enthalpy of combustion, we have to divide the total amount of heat, in burned in joules, or the heat given out in joules, we have to divide it by the number of moles of ethanol that was burnt, because we need to figure out, remember, they've asked us in kilojoules per mole. So we need to figure out how much heat energy in kilojoules, sorry, was given out per mole. So we need to divide this by the number of moles of ethanol. And how do we calculate the number of moles of ethanol? We know the formula for moles. Moles is equal to the mass of the substance divided by the molar mass, right? And we know both these things. We know the mass and we know the molar mass. So the loss in mass of ethanol, or the number of, or the mass of ethanol burnt, was 0.230 grams. We see that over here. They've given it to us in the question. And the molar mass of ethanol is also given to us. Wow, they've made our life so simple, which is very unlike the IB. And we know that the molar mass of ethanol is 46.08. So these are the number of moles. And you might look at this and think, oh, okay, we're done with our job here, but not quite, because remember, the heat energy that we have calculated, or the amount of heat that has been given out, we have calculated in joules. Q is equal to MC delta T. Q is, the unit for Q is in joules. But we need to calculate the enthalpy of combustion of ethanol in kilojoules per mole. Now, in order to convert from joules to kilojoules, we have to divide by 1,000, right? So we simply put 1,000 over here, because we're dividing this whole thing by 1,000, right? And that's it. That will give you your answer. And that would be answer number C. That is the correct answer as well. So I hope you've understood what I've done. So let me just run through the steps again. The first step is calculate Q. Whatever is Q, you don't have to solve it immediately. You can just leave it in this form over here, like I have done. I've just left it in this working form. Then find out the number of moles of the substance that you need to figure out the enthalpy of combustion for. In this case, we needed to figure out the enthalpy of combustion for ethanol. So we found out the number of moles of ethanol, that over here. And last but not least, do not forget to multiply, or actually divide this by 1,000. Don't forget to do that, because you need to find out the enthalpy of combustion of ethanol in kilojoules per mole, not joules per mole. So if, supposing I did not multiply this by 1,000, your answer would be wrong. If I left it like this is wrong. This is not the right answer, because remember, always be careful of the units. So that's why divided by 1,000, right? Now, last thing, why is there this negative sign everywhere? Why is this there? Well, Let's not forget, we are talking about enthalpy of combustion here. That means that we are burning something. Now, have you ever burnt something and have you ever felt a cooling effect in the environment? No, you've not. You've always felt things heat up. That's because burning or combustion is an exothermic reaction. And for exothermic reactions, the enthalpy change delta H for combustion reactions or anything burning is always negative. A negative enthalpy change signifies an exothermic reaction, and combustion or burning is an exothermic reaction. That's why there are these negative signs everywhere in all these options, because that's what the correct or that's what the enthalpy of combustion is. Enthalpy of combustion is always negative because you're burning something. That's why there's a negative sign. Hope you understood that. Anyways, we are done for this video. I hope that you've understood the concept and I hope that this will help you in your exams. If you have any questions, please feel free to message me on my social media, send me an email or put it down in the comments below. I'll be more than happy to help you. Thank you so much for watching and I will see you in another video with a new question.